Welcome everyone to Module 1, Python Programming for AI/ML. This course is brought to you by the Series of Thoughts Tech Team. Today we'll master the essential tools and techniques for building artificial intelligence and machine learning solutions using Python. Let's dive in. In this session, we'll focus on setting up your professional AI/ML development environment. We'll cover why Python dominates the AI/ML field, how to install essential tools, and how to configure your workspace for maximum productivity. Python has become the industry standard for AI and machine learning development. Major companies like Google, Facebook, and Netflix rely on Python for their machine learning infrastructure. Its readability and extensive library ecosystem make it the go-to language for both research and production. Python offers a rich ecosystem with thousands of specialized libraries for every ML task imaginable. It has a massive, active developer community providing abundant tutorials and support. Its syntax is simple yet powerful, making it accessible for beginners and robust for complex systems. Plus, it integrates seamlessly with production systems and cloud platforms. While Python dominates AI/ML, other languages like R and Julia have their strengths. R excels in statistical analysis and visualization, while Julia offers high-performance computing. However, Python's ease of use, comprehensive libraries, and industry adoption make it the clear choice for aspiring data scientists and ML engineers. Let's explore different ways to install Python and why some methods are better suited for AI/ML development. We recommend Anaconda because it bundles Python with over 250 pre-installed scientific packages, saving you setup time. It manages dependencies automatically and includes essential tools like Jupyter Notebook and Spider IDE. Step by step, download the installer from anaconda.com, run it, choose installation options like adding Anaconda to your path, and verify your installation by checking the Conda version. Miniconda offers a minimal install for experienced users wanting more control. The official python.org install works for general programming but requires manual setup for ML libraries. For beginners, Anaconda is the best starting point. Jupyter Notebooks revolutionize data science by combining code, visualizations, and narrative text in an interactive document, perfect for exploratory data analysis and experimentation. Unlike traditional scripts, Jupyter lets you run code in any order, see immediate results, and document your thought process alongside your code. This interactive workflow is standard for data science prototyping. Jupyter Notebook is simple and great for beginners, while Jupyter Lab offers an advanced IDE-like environment with multiple documents and extensions, ideal for complex projects. Open Anaconda Navigator, launch Jupyter Notebook or Lab, create a new Python 3 notebook, and get ready to explore the interface. Key components include cells for code or text, a toolbar for common actions, the kernel that runs your code, and a menu bar for settings. Cells can be code, markdown, or raw text. Master shortcuts like Shift plus Enter to run cells, A/B to add cells, DD to delete, M/Y to switch cell types, and Control/CMD plus S to save your work frequently. Let's write a simple Hello AI 1050th World program in the first cell and run it with Shift plus Enter. Congratulations on running your first Python code in Jupyter. We'll install essential ML libraries like NumPy, Pandas, Matplotlib, Seaborn, and Scikit-learn using Conda, which handles dependencies smoothly. Conda manages scientific packages and dependencies well, ideal for ML libraries. Pip is faster and has more packages but less dependency management. Use Conda first, then pip if needed. Conda manages scientific packages and dependencies well, ideal for ML libraries. Pip is faster and has more packages but less dependency management. Use Conda first, then pip if needed. Create a new notebook and import each library. Run a quick visualization using the Iris dataset to confirm everything works. Document your project's packages with requirements.txt using CondaList, export, or pipfreeze. This helps recreate environments and share setups. Explore when to use Jupyter Notebooks for exploration and prototyping, and traditional IDEs like VS Code or PyCharm for production-ready code. Here is a look at when it makes sense to use the Jupyter Notebook versus when to use the more traditional IDEs. VS Code is popular for Python development with features like IntelliSense, integrated terminal, debugging, Git support, and native Jupyter Notebook support. Install VS Code, add the Python extension, select your Anaconda Python interpreter, and configure your workspace with helpful extensions. PyCharm offers a professional edition with advanced features and a free community edition. It provides sophisticated tools, but is more resource-intensive. Most data scientists use a combination: Jupyter for exploration, VS Code for scripts, and PyCharm for complex applications. Use Git and GitHub for version control, get comfortable with command line tools, and consider Docker for containerization in advanced workflows. Use Conda environments to isolate projects and manage dependencies. Create, activate, install packages, and deactivate environments as needed. Check your Python interpreter. Use Anaconda prompt if Conda commands fail. Resolve package conflicts by creating fresh environments, and register Jupyter kernels properly. Run a comprehensive test in Jupyter importing libraries, training a random forest model on iris data, evaluating accuracy, and visualizing results with a confusion matrix. We covered why Python dominates AI/ML, installing Anaconda, mastering Jupyter Notebooks, essential ML libraries, and IDE options for production. Your assignment is to install Anaconda, launch Jupyter, create a notebook named my_first_ML_environment, import libraries, write a Hello World program, create a plot, and save your work. Next, we'll dive into NumPy fundamentals, Pandas for data manipulation, data visualization, and machine learning basics. Join us for the next module on NumPy fundamentals, where you'll learn array operations, broadcasting, mathematical functions, and real-world ML examples. Thank you for your attention, and see you in the next module.